Eric is already with us. Hello, Eric. Wonderful to see you.
Hello. Good to be here.
Truly a pleasure to have you with us today. Eric, you are the Global Head of Analytics for GDD at Novartis. You were previously Head of Biostatistics and Pharmacometrics for Pharma, as well as Biostatistics Franchise Head for Immunology and Dermatology, both at Novartis. You've also worked at Pfizer, Abbott, and Wyeth in the area of CV and metabolism, immunology, and infectious disease. You have a very broad range of experience from the medical field. A PhD from Kansas State University in statistics, and has led teams of quantitative scientists for 25 plus years. And today we're going to listen to you talk about statistical leadership and greater statistical thinking. A warm welcome.
Thanks very much. Thank you. I'm just going to share my screen.
One moment. Also, remember, Maria had a question for you.
Sure.
That you're free to answer either straight away or during your presentation. And the question is, statisticians often rightfully complain about how journalists misunderstand and misrepresent statistics. But can you think of any good example where the reporter actually did a good job in presenting and using statistics? So feel free, as I said, to answer that question either straight away or during your presentation. And with that, I'm going to let you take it away.
All right. Yeah, so in terms of working with journalists, I can't say that I have so much experience answering questions directly from journalists, but I think I can at least answer that question indirectly by offering some good advice from a couple of experts who have, I think, had some considerable experience during COVID, dealing with journalists and addressing some of their questions there. So I'll get to it a little bit later. With that, I'm going to share my screen and get started. And then just put this on slideshow. And I think there we are. So again, I appreciate the opportunity to be here today and to talk to you a little bit about statistical leadership and what I would think of as greater statistical thinking. I'll explain a little what I mean by that as we get into the presentation. So why so much concern about statistical leadership? I think the answer hopefully is obvious. Data seems to be raining on our heads these days because scientists are generating data more rapidly than ever. And with the advent of our computing era, we find huge sources of data and indeed big data that's driving, I think, an increasing need and an exciting opportunity for statisticians and other folks with statistical skills. And the growth of big data creates a lot of opportunities to collaborate on a series of questions that relate to bias and false discovery and generalizability in the context of data that is probably not a sample. It's not from a designed experiment or a planned survey, but instead it may represent data, big data from various sources, and at times it may represent almost the entire population. And so this era of big data opens up a whole new array of questions and a whole new, I think, series of possibilities for statisticians. So scientists are hungrier than ever for input from statisticians. They're interested in working with us and collaborating with us, and they need our help. But the irony here is I don't feel we're engaging and speaking up in the way that we should, and really fully realizing and taking advantage of all these different opportunities that are right in front of us here, particularly in this modern age. And the missing ingredient is statistical leadership. And in my work in clinical drug development, we work in multidisciplinary teams that are working to develop new candidate drugs that we think may make a difference in the life of patients in need. And so we work in a multidisciplinary setting. We work in multidisciplinary drug development teams. And so I tend to think of statistical leadership as the use of influence without authority to guide the designs and strategies and decisions based on data when you're working in a multidisciplinary team and collaborating on projects over a longer term period of time. And so I think statistical leadership is not only a missing ingredient, but an important opportunity for us. If you think about some of the core competencies of statistical leadership, I would start with statistical thinking. And statistical thinking really uncovers the relationship between data and a real world problem in the presence of variability and uncertainty. This was a definition put forward by Colin Mallows back in 1998. And it's a really nice definition and a really nice way of thinking about what a statistician brings to the table when you're working with a multidisciplinary team. You are able to help them make the link and see the link between a real world problem and different sources of data that may relate to that problem. And in some cases, it's designing an experiment or planning a survey to address a problem or a question. But increasingly in this contemporary era, it may be looking at other sources of data, and indeed data that doesn't come from designed experiments that may relate to a real world problem. And then another aspect of statistical thinking is, I think, best illustrated by George Box, who has a delightful quote that statistical thinking requires the wit to comprehend complicated scientific problems, the patience to listen, the penetration to ask the right questions, and the wisdom to see what is and isn't important. And if you unpack what George Box said all the way back in 1976, you find a couple of really important components. The wit to comprehend complicated scientific problems means, I think, in part that you have to invest in the language of the team that you're collaborating with. You have to invest in understanding the subject matter that the team is focused on. And in my case, if you're collaborating with a team on a drug development project for multiple sclerosis, as a statistician, you certainly don't need the level of depth of a trained physician or a neurologist who has spent their life working in multiple sclerosis and working with patients, but you need to understand the language of the therapeutic area. You need to understand what is it about MS patients that we're trying to treat? How does their disease progress over time? What type of measurements do we take from patients with multiple sclerosis? Why do we take MRI images of their brain? Why is that important? How does that link to the progression of disease? So you have to invest in that domain expertise, that subject matter that the team is really focused on, so that you can speak their language and really work effectively with them. And you also have to have the patience to listen and to ask a lot of questions. And I think this would be active listening, not only listening, but asking questions and working within the team. And oftentimes what a statistician brings to the table is really helping the team to better understand what their question actually is. What is their research question? What is the problem that they're trying to solve? And even when teams have a general idea, or they may think they have a very focused idea, often the working with a statistician and interacting with a statistician helps the team bring their idea in better focus, and they get a better, more crisp idea of what really the research question is that we should be tackling with this design, with this experiment, or with research into big data. And then, of course, the wisdom to see what is and is not important. I think getting lost in the details is always one of the pitfalls for statisticians when we collaborate with multidisciplinary teams. The second core competency is networking. A multidisciplinary team is a network of relationships. And it's important to really be proactive, to get out and interact with the team, and to really invest in personal relationships with the team, to meet them, to understand a little bit about their background, what is their expertise, what do they bring to this project, what are their objectives, what are they looking to get out of their experience working and collaborating on this project, what are they advocating for based on their expertise. And it's important not to wait to be approached with a request. Statisticians have a tendency sometimes of being a little too passive in waiting to be approached, waiting to be invited to an email, to a meeting, or waiting to get an email with a specific question. And it's important that if you're collaborating, that you bear in mind that it's not a service-oriented transaction. You don't want to project yourself as a clerk at a statistical help desk. You really want to engage with the team, immerse yourself in the collaborative efforts of the team. And bear in mind that down the road, if you want to influence the team towards a different design, a different strategy, a different endpoint, that influence, the ability for the team to really accept your guidance as credible guidance that may reshape their opinion, it's going to depend on the relationship capital that you build up with the team over time. And the third and last core competency, and I suppose you could come up with many core competencies of your own, but for simplicity, I try to focus just on three. And the final core competency is communication. One of our past presidents of the American Statistical Association, Nancy Geller, I think said that the most important thing in statistics is communication, communication, and communication. And it starts with speaking up. One of the things I've noticed over my 25 years working as a statistician in drug development and working with other statisticians and developing statisticians in their career is sometimes there's a lag. We fail to share our ideas in real time, and we wait sometimes until the next meeting. We want to think about it and be very careful and frame our ideas very carefully. And so oftentimes we're waiting when we should be speaking up and sharing our ideas in real time. If you wait on your team, if you wait until the next meeting with your team, oftentimes the moment is past, or when you do share your ideas, they have less impact if you had shared them during the conversation when your ideas were most pertinent. And I think importantly, we have to make sure that we use statistical jargon sparingly. There's no question that we have to use it when we collaborate with our multidisciplinary colleagues. And if you're collaborating on a group sequential design for a clinical trial looking at relapses in multiple sclerosis patients, it's impossible not to use a bit of statistical jargon in that collaboration. But it's important to try to keep it to a minimum and to tailor your message to your audience. And to understand that your audience is largely going to be non-quantitatively trained folks. And so preparing for the interactions that you have, whether it's a meeting with your team or whether it's presenting your ideas, whether it's presenting the results once the collaboration is nearing closure, preparation is the key. Larger audiences require more preparation. If you're speaking just to a couple of colleagues informally, doesn't need that much preparation. We don't have to get too neurotic and prepare for weeks in advance for a hallway conversation with just a couple of our colleagues. But if you're presenting to a larger group, if you're presenting to 12 or 20 or 200, as the size of the audience increases, so must the preparation. It's important to strive for simplicity, regardless of what your intended audience may be, and to adapt the message to the audience. If you're speaking to a group of statisticians, certainly you can incorporate a bit more statistical and technical elements of statistical jargon. But if you're speaking to a non-statistical audience, you have to adapt the message. And coming back to the handover question about dealing with journalists, there's an excellent paper by McConway and Spiegelhalter that just came out earlier this year. And it's a wonderful overview. And it's focused on communicating with the media and communicating with journalists during the COVID pandemic, and they share some of their experiences and what works well and some of the pitfalls in communicating with journalists. So it's a great way to indirectly answer the question that was posed at the outset of the handover to this presentation. And what you find as you read it, a lot of the themes that they talk about really could apply to almost any interaction that you're having as a statistician. Now, influence requires a positive attitude. So if you have this foundation of these three core competencies, and then you want to seek to influence a team on the best design or a decision. In my work, you might want to influence a team on a portfolio decision as to whether or not we should continue with a drug development project or invest a little further into it, or whether the data maybe suggests that we should cancel or terminate and not invest anything further. So when you're seeking to influence as a statistician, the attitude is critical. And there's a couple of blind spots that I would really counsel any statistician who's working on their career development just to be aware and watch out for a couple of classic pitfalls. One is sometimes we come across as the naysayer. Our training naturally sort of lends itself to focus on uncertainty and risks and type 1 error. But the tone and the timing are critical because if you react too quickly to suggestions in a multidisciplinary team setting or in a collaborative setting with a bit of a negative attitude or quickly reacting with too much intense focus on risk or type 1 error, you can fall into this trap of being viewed as the naysayer who comes with a bucket of cold water. And there's no question that one of the roles of a statistician is to advise people about the risks. And so that continues to be a critical element that we bring to the table, but how you do it is very important. So there's no question that that's one of the things that we should be doing, but that's one of the areas where we tend to lose people. The other pitfall is the policeman. We have a tendency to think of ourselves as the police of science. And when we have other people that are making suggestions as we collaborate with larger teams, you have to be careful that we don't drift into the work of policing the ideas and the suggestions of other folks on the team. Give them an opportunity to share their ideas, to bring their ideas forward. And if you have advice or feedback on those ideas, the tone and the tenor and how you do it is very important. The other aspect about influence is that it takes time. The key element, I think, for influence is investing the time to develop the relationship with a team you're working with, so that the level of influence is consistent with the type of relationship and the amount of credibility you've built up with the team. And you don't want your influence to get ahead of a relationship. If you've only worked with a team for a short period of time and they don't know you very well, then advising them to cancel a $100 million program based on the data, that may be a heavy lift without the appropriate investment of getting to know the team and for the team getting to know you a bit. And recognize that multidisciplinary teams, collaborative teams that we work with, are seeking clear recommendations from us. And so it's important to avoid ambiguous statements. You need the courage to sometimes just say, look, there's not enough data really to make a data-driven decision here. So if you really have to make a decision today about the portfolio or about a project, unfortunately, you're going to have to make it really based on other factors. There's just, the data is too limited to really inform this decision. And then, you know, when you're influencing teams, it's not about winning or being right all the time. It's about making sure that you're sharing your ideas, you're being heard within the team, and that you're having good discussions with the team, and that the team is able to make decisions with a full appreciation of the data, the risks that are related to the different strategies that they may be entertaining. Now, one example of influence at a scientific and public policy level from my area of work is MCP mod. MCP mod is a methodological approach that we began to try to push for adoption back in 2002. In my organization, some of my colleagues developed an internal initiative, and they were seeking to use model-based methods in dose-finding trials, to use more of a model-based approach to selecting the best dose for our patients. And so what they proposed is to entertain an array of candidate models that you see at the right, for models that represent different shapes, different candidate shapes to the dose response curve. We use multiple comparison methods to evaluate and select those models that have the strongest signal among the whole set of candidate models. And then from that, we use model selection or model averaging to estimate what we think is the best target dose to carry forward into confirmatory testing. So this whole approach of using a model-based methodology for really selecting and optimizing the dose in drug development is something that took, well, it took a long time, about 14 years. 14 years of working with partners in science, in academia, partners, scientific partners at different health authorities and regulatory authorities, publishing in the literature, presenting papers at conferences, and ultimately, towards the end of this period, we were able to get a qualification opinion by the EMA and a fit for purpose designation from the FDA. And indeed, today, this is really the way that we go about optimizing our dose for our patients. So this is an example of influence, working more at a scientific and public policy level, working across academia, regulatory, and industry. And really, it took 14 years because we were seeking to really change the way in which we approached dose-finding trials in drug development. Now, beyond some of the traditional work in clinical trials, it's also important to navigate both cultures. Leo Breeman talked about the two cultures of an exploratory and confirmatory culture or attitude for statisticians and data scientists. And the contemporary statistician, really, it's crucial that a statistician working today has the flexibility to move back and forth between the exploratory and the confirmatory attitudes, depending on the work, and to really be able to embrace both cultures. Increasingly, we're finding that scientists want substantive collaboration, and not just on traditional designed experiments. They want collaborative input and guidance from statisticians in terms of doing research with larger data. Rather than designing an experiment to generate data, we're finding more and more that we're also being pulled into collaborative work where we're doing research with data from a variety of different sources. Now, data scientists, they tend to have a can-do attitude, whereas statisticians sometimes are perceived a bit as the skeptic, particularly when it comes to exploratory work. And I'll give you an example of exploratory work in just a moment. Now, data science is an opportunity. I think statisticians, if you want to really develop into a good statistician that's able to bring value into collaborative work, then part of your leadership journey should include an appreciation for data science as an opportunity, and to appreciate that, you know, the unique capabilities that these alternative disciplines have. And if you can combine that together with a more flexible attitude towards data exploration, I think you'll be well poised to take advantage of data science as a great opportunity. Now, data science, machine learning, pharmacometrics, bioinformatics, and many, many other quantitative disciplines, these are neighboring disciplines with whom statisticians share some common language and customs. But it's important to recognize that each of these different disciplines have quite a few elements that make them unique and different. Now, statisticians and indeed other quantitative scientists from some of these disciplines have an opportunity to achieve greater impact through collaborative leadership, where now we're finding that these larger multidisciplinary and collaborative teams have a statistician and a data scientist, or a statistician, a data scientist, a computer scientist, or a statistician and a bioinformatician and a machine learning expert. It depends on the project, but more and more we're finding that these multidisciplinary teams have multiple team members that may bring different skill sets from some of these neighboring quantitative disciplines. And so it requires of us, I think, greater statistical thinking. And by greater, I mean, and I'm borrowing from Chambers here, that greater statistics is learning from data by preparing, analyzing, and presenting data. And I think also borrowing a bit from Tukey, we need both the exploratory and the confirmatory mindset as attitudes that are important for statisticians working today. And it's important to think about the problem, to identify and wrangle relevant data, to integrate and explore the data before you then shift into the deeper analysis where you want to develop and select and validate a model, and then hopefully communicate some insights from this type of data exploration that we're finding ourselves doing much more of in this modern age. And I'll close with an example, and this is my last slide, of greater statistical thinking. At Novartis, we're in the midst of a long-term collaboration with Oxford University's Big Data Institute. And one of the things that brought us together as an opportunity for collaboration was the library of clinical data that we had from over 34 completed clinical trials in the field of multiple sclerosis. So 34 clinical trials across 57 countries, totaling 35,000 patients or thereabouts. The overwhelming majority of them having relapsing multiple sclerosis, an important subset of them having progressive forms of multiple sclerosis, and quite a bit of the data being high quality data coming from randomized controlled clinical trials. Within this cohort, we have a broad age range of patients, a broad range of disability, multiple, and in fact, all of the major phenotypes for multiple sclerosis, pediatric MS, relapse remitting MS, primary progressive MS, and secondary progressive MS. Long-term follow-up data, laboratory data, patient-reported outcome data, biomarker data on these patients, and importantly, over 200,000 MRI images of the brains from approximately 10,000 patients. So we have this huge integrated source of data. And so under this idea of greater statistical thinking, learning from large integrated sources of data, such as we have here from all these completed clinical trials, we sat down with our collaborative partners, and the problem, going back to the previous slide and thinking about greater statistical thinking, the problem, of course, is what can we do to leverage this data to really learn about the disease progression and to model disease progression in multiple sclerosis. In terms of identifying the data, this cohort we felt was really the cohort of data that was best suited to really put us in a position to do a lot of the modeling of disease progression that we felt was important. And wrangling the data. Well, my goodness, I could probably talk to you for a couple of weeks about all the data wrangling, but just one component was anonymizing the MRI images. When you take an MRI of a patient, you actually capture in the course of the MRI an image of the patient's face. And so we developed algorithms to deface, or in other words, anonymize the images. And then we needed to develop some neural network methods so that we could make sure that we had the right quality control to evaluate the quality of the defacing of the images, and to make sure that we were validating that we really were achieving the anonymization that we were seeking to do. Now, the model selection and developing models and really getting into the next phase of the research, that's ongoing. And so hopefully you'll get to see a little bit about that in the literature in the coming months and this year and next year. But this is an example of greater statistical thinking, where we're coming together to do research, exploratory research with integrated data. And instead of a strict hypothesis test in a clinical trial linked to an objective that's prospectively planned, here we're going and retrospectively analyzing a large cohort of integrated data and really with just a broad direction of the research rather than the really hyper-specific pre-planned null hypothesis that we're accustomed to in a lot of our clinical trial work. And so navigating back and forth between both types of work, I think, is a part of our future as statisticians. I think that brings me to the end of the presentation, and I have a few references here that I'll leave on the screen for a few beats. And I guess I'll turn it back to Matthias to moderate any questions.
Excellent. Thank you very much. It was truly a pleasure to hear you talk about this. As mentioned, it was your article in the American Statistician that actually sparked the theme of this entire conference, statistical leadership. So thank you very much for writing that piece. If you haven't read it, and in our audience, please do. It's very, very insightful. So let's open it up to questions. You can either write them in the chat box, raise your hand, or simply just unmute yourself and ask a question. While you let that meander, I'm gonna fire away some questions that have come in on the side here. So we're still and have been for a year and a half, almost 2 years, living in a pandemic where people have been working from home. So how have you been working to develop statistical leadership with your team in this remote work setting?
Well, it's a great question, and it's certainly not an easy thing to do. I think one of the benefits is that the technology allows us to come together as teams, and really, I think, levels the playing field a bit, whether you use Zoom or Microsoft Teams. I think people are able to participate and contribute to the conversations in a much more straightforward way. And I think it's easier to get more inclusion from the folks who are collaborating and working. I think it comes back a little bit to relationships. You have to find new ways to cultivate relationships, to get to know people, to work with people, and also just to continue to invest and sort of sustain the relationships that you already have. And when you're not able to see people face to face, as we were pre-COVID, certainly not the way we once did, it is a challenge. So I think, you know, I find that ringing people up by phone, having a one-on-one call, ad hoc calls via Teams or Zoom becomes important. And then to the extent that you can try to meet people directly, obviously that becomes much more limited. That's always a welcome benefit also. But if I wish I had a perfect answer and a formulaic solution of how to cultivate and maintain leadership in a COVID era, but I think you just have to try to take advantage of the technology and engage through this new technology and be willing to experiment and be creative and to take feedback from other people.
All right, brilliant. Thank you. Yeah, don't we all wish we had the answer to how to actually manage this brand new way of working? You mentioned it's important to not come across as a naysayer or a policeman. Do you have an example of how to bring forth negative feedback or criticism in a way that's not posing you to be a naysayer or policing?
Yeah, I think it's about timing. So, you know, if you're coming into a meeting and it's a 90-minute meeting to talk about the design for a project, I think it's about timing and tone. You may have important feedback that you need to give based on some risks associated with the project. But do you lead into the meeting with that being the very first thing you say at the outset of the meeting in a very strong tone? Or do you work your way up to that? And if you're advising people on the risks, so sometimes I advise people, actually just a week ago, we had a decision about whether to invest a significant sum of money to do some additional work on a project. And so because I had conveyed some of my thoughts over a period of weeks, because it was not the first time I was giving this feedback, and I had given it a little softer and given it several times because I knew there was a meeting coming where we were going to take the decision. And so I sort of undertook a strategy to pace, to take advantage of the pace of meetings and to position some of the earlier interactions with the team so that when I did want to come a little more firmly and a little bit more clearly with the recommendation against moving forward, it was not coming like a shotgun burst out of left field just at one meeting. So again, it's about investing the time, it's about the pacing, and it's about how you're perceived by the team. So there's no doubt, sometimes we have to advise or push back on a certain direction for the research or advise based on the data to take a decision that may be a little bit tough to take for the team. And those are specifically the types of interactions where you don't want to do it as a shotgun blast in one single interaction. You've got to lead up to that and make the appropriate investment so that when it does come time to take the decision, it's more natural. And it just is an issue of coming to the meeting and just a little nudge pushes it over the edge because you've done the work in advance over the previous several weeks.
That's an interesting approach, but I guess the classic acronym, the prior preparation prevents poor performance, really rings true even here.
Yeah.
Another question that have come up, data scientists and data science has really become a hype area in the last couple of years. And some feel that is just a different way of reframing statistics. But you mentioned that there are unique qualities to different approaches that you need to recognize. Would you care to elaborate on some of the unique approaches that data scientists bring apart from statisticians?
Yeah, I think, so I guess I would make 2 points. I think it is true that folks that are, a lot of universities, certainly in the last 4 or 5 years, are offering an increasing array of master's degrees and even PhDs, doctoral programs in data science. And as we hire some of those folks into my organization and work with them, we find that they have a more exploratory attitude, a more of a can-do attitude, a bit more of an adventurous attitude, which is not to be confused with like a reckless abandonment of evaluating the risks and type 1 error and false discovery, but they're more interested and intrigued with exploring data and engaging with the data. And they tend to have some really good computational capabilities to do so. And I think those are attitudes that the statisticians need to cultivate a bit further. And it depends on your line of work, but in my particular line of work, many statisticians that have worked in drug development have focused a lot on more of the classical elements of designed experiments, and indeed analyzing some data and exploring some data as well, but not in the way of exploring larger integrated data or more complex integrated data the way that data scientists do. And so I think there's an opportunity to embrace more of an open mindset. And I think we get hung up on the term data scientist. There are lots of statisticians that you could think of as data scientists, that they also are data scientists. They have strong computational training. They enjoy exploring large and complex integrated data. And that may be a significant part of what they've done in their career. And so while their formal degree may be in statistics, they certainly work and act as a data scientist. I've worked with pharmacometricians and bioinformaticians that have really strong data science capabilities. So these are overlapping disciplines, and they're not mutually exclusive disciplines. And we really worry about the definition and where to draw these rigid boundaries. My PhD is in statistics. At the time I came out of the university, we weren't really talking, of course that was a long time ago, but at that time, 25 years ago, we weren't talking about data science the way we do now. And what you find is that new graduates coming out of the university have a lot more variability as opposed to my graduating class that probably came out with a little less variability in our training. And so statisticians have a variety of different tracks that they pursue in their program. Some of it's intensely computational, data science and machine learning. Other statisticians such a track. So these are overlapping disciplines. They share some things in common. They have some things that I think are unique. It also depends on the person. What's important is that the mixture of it results in something that's much more powerful. So in the Oxford example, we have multiple statisticians, we have data scientists, machine learning experts, computer scientists, imaging experts, radiologists, neuroscientists, a variety of MDs with specialties in neuroscience. We've got this large integrated multidisciplinary team, but there's multiple quantitative disciplines at the table on this particular team. And I think that's a good thing. I think that's something to be celebrated. And it creates a lot of opportunities, regardless of what the nuances are of your quantitative background.
All right, wonderful, thank you. Another question that have come in is leadership in a multidisciplinary environment is not necessarily a zero-sum game, but have you experienced competition when statisticians claim more influence?
Yeah, I have, and it's probably, I think competition never ends well. I think for me, it's all about collaboration. Everybody, and again, I can only speak to the field that I work in, but in the field of drug development, everybody at this multidisciplinary table has drug development expertise. It may be from a regulatory, clinical pharmacology, a chemical, medical perspective. It may be from a data science, a machine learning, or a statistical perspective. Everybody has some expertise that they can contribute to the collaboration. And so I think it's less about ownership of, there's a territory, and as a statistician, I own everything in this territory. It's more about what can I contribute to this collaborative team that's going to move the science forward. And if I work with a data scientist or somebody who has expertise in a machine learning background, as we are with our Oxford collaboration, it's actually some of the most exciting and most interesting work that I've ever seen in my career. And nowhere in that particular collaboration is there any competition or territorial aspect to it. It's just a bunch of people that are really excited to drive for the best science. And there's room for everyone. I have a PhD in statistics, but I have a data scientist working on this project as well. And he has his doctorate in data science, and his specialization is in how to deal with the voxels in images in MRIs. I don't have that expertise. I don't know much about that. And what a wonderful thing it is that I have this guy that's a part of this team that can really drive the science forward.
Wonderful. That's truly inspirational. Thank you very, very much, Eric. It was truly a pleasure having you with us.